as I was saying, this is Science with Ms. Steph, folks. We are continuing our series, okay? It's a series on times 10, the impact that multiplying anything times 10 can have. And so I want you to continue to send in your request. I also want you to continue to participate in what we are doing. I mean, there are so many different ways that you can participate and engage in the Ms. Steph Science Club community. You can join us on Saturdays live at 2:30 over here on Facebook. You can come a little early and hop on Instagram and get to see the end of the experiment before we actually do it, and then come over to Facebook. You can do that. You can also, of course, contribute. You can make contributions, and I will make sure that you know how to do that. All of that stuff is going to be available to you. And of course, you can attend all of our programming. It's really important for everyone to know that we are getting ready to resume. Okay, resume and upgrade. We're resuming in-person programming as of May 29th for Saturday program. And then, yes, we are going to have in-person programming for Summer Science Club 2021. All of those links I'm going to put in the description box for the Facebook as soon as I get off of here after shooting the live. And then, of course, YouTube. Hello, like, share, subscribe, all that stuff for my YouTube people. When you're watching this down the line, all of that stuff will be on for you all as well. Once again, welcome. Hi, I'm Ms. Steph. Welcome to one of the various labs in my home. I turn everything into a lab. That's just kind of how I am. I've always been that way, even since I was a kid. So for all of you young scientists out there, this is where it starts. Welcome, welcome, welcome. Today we're going to do 3 things. We're actually going to do 3 different reaction vessels today. We're going to bring over our friends, the Flask. Okay, we've got 2 sizes of flasks today. And I'm also going to show you a little something with a balloon and a, what's that thing? A soda bottle, right? Reduce, reuse, recycle, folks. Reduce, reuse, recycle. Okay? So our theme material today is the Alka-Seltzer. All right? As promised, when you come on Facebook, you know you're going to really get the breakdown of what's happening. So this is an Alka-Seltzer tablet. Okay? Alka-Seltzer tablet. And Alka-Seltzer tablets are really designed for a specific thing. They're actually a type of medication. Okay? So let's talk briefly about what they're supposed to do as far as medically, and then we'll have some fun with exploring as far as the actual reaction when we add it to water. Yeah? Okay? So how does Alka-Seltzer original work, right? Okay, the original thing that you're supposed to do with Alka-Seltzer. Alka-Seltzer original effervescent tablets contain 3 active ingredients. Did you know that? Aspirin, which is a pain reliever, sodium hydrogen carbonates, and citric acid. So we have a base and we have an acid. That's the thing that we play at and engage with when we're doing our science investigations. But then there's also aspirin, which is also one of the big reasons why I'm always saying, okay, we don't eat our science. This particular activity is quite dangerous to eat, okay? We're not going to eat it, ever. Okay, aspirin belongs to a group of medicines called non-steroidal anti-inflammatory drugs, NSAIDs. Okay, Motrin is inside of that, and some other things. Okay, it works by blocking the action of an enzyme. Guess what? Enzymes are catalysts. Didn't we talk about catalysts last week? Yeah, all of those things. Remember how I'm telling you, like the reactions in the body and By the way, I went to school for biochemistry, and so that's why I'm always so excited about biology and chemistry coming together, right? Because that's what I went to school for. And so, yeah, enzymes are things that help reactions go. Okay, they help break other things down. They do a lot of other things, but one of the functions that they play is they can be catalysts as well. All right, so yeah, so you have that component, the pain reliever. Okay, because really people take it for an upset stomach. Okay, upset stomach, which really is a really broad array of conditions, but this is an over-the-counter thing, something you get at the quote-unquote the drugstore to help your tummy, okay? And they also it also contains the sodium hydrogen carbonate and the citric acid. So my base and my acid, that is the stuff that's going to come together and form the carbon dioxide. It's a very similar reaction to our vinegar and baking soda. Okay, so the vinegar and baking soda reaction can be mimicked in a way by doing Alka-Seltzer and water. Then you can even amp up the reaction by using vinegar with Alka-Seltzer. That's a whole nother level of stuff. But for today, our main focus, our main fun is going to be adding Alka-Seltzer and water together to produce gas, to get that carbon dioxide, the bubble, the bubble, the bubble, the bubble, the bubble. And we are going to enhance the bubble. We're going to enhance things by adding soap, of course, and some food coloring. And of course, we're going to do our 1x reaction because it's May. We're multiplying times 10. We're going to do a 1x reaction and a 10x reaction. I repeat, we're doing a 1x and a 10x reaction. Before we do that, shall we, you and I together, observe what happens when you mix together Alka-Seltzer the way it says to do so on the instructions. Let's find out what happens there first. Right? Also, for those of you watching, thank you for joining me, Miss Steph here. Please give me a sound check. Let me know. Can you hear me? All right. Can you hear me? Please let me know. Let me know. Let me know. Let me know. All right. So yes, like I said, we're going to start off with a base. Kind of not a, I don't want to say base because that confuses things. We're going to start off with kind of a control. All right. Let's find out what happens when you just mix Alka-Seltzer the way they say to do it on the package. It says completely dissolve 2 tablets. Here are 2 of my tablets. 2 tablets inside of 4 ounces of water. Okay? By the way, 4 ounces of water is a half a cup of liquid. So I'm going to measure. You see, it's very important to measure things accurately. I'm lifting it up today just so that you can see what I'm doing. Okay, this is my half cup measure, and there we go. We're getting that nice effervescent. I didn't have trouble saying it. Reaction and action. Do you hear that huge, big fizz? Are you hearing the fizz that's happening? It's loud, this reaction. It's very, very loud. Here are the bubbles, bubbles, bubbles. The amazing thing about Alka-Seltzer tablets is that they are designed, chemical and medical engineers designed this. Alka-Seltzer tablets are designed, as you see, to dissolve without having to mix or stir, right? So you give it a swirl, right? To make sure it's all dissolved. And you notice they readily dissolve, okay? That was 2 tablets in just 4 ounces of water, which really is not very much, okay? If this were the same amount of salt, I would have to stir it, okay? It would take some manual assistance, all right? So anyway, I'm going to put this to the side. So we know what happens. Alka-Seltzer water, okay? And this is what someone would drink for medical purposes. Now, we're going to have some fun, okay? We're going to have some fun. It looks like the light is shifting a little bit, so let's help ourselves out. We're going to have some fun, and start to do what you and I normally do, right? We're going to observe and investigate. So, as I indicated before, we're going to do a 1x, okay? We are going to do 25 milliliters of water inside of this 150 milliliter beaker. 25 beaker, forgive me, flask. This is a flask. 25 milliliters of water in here, okay? And then we're going to go with actually 250 milliliters of water inside of here. We'll have 10 Alka-Seltzer tablets inside of that one. And of course, just 1 Alka-Seltzer tablet in this. In addition to our Alka-Seltzer tablets and water, we're going to add 2 other components to our reaction chambers. We're going to add some soap. Be able to tell me by now why we're adding soap. Why do we add soap to reactions? I talked about it last week a little bit. We're going to add some soap. And of course, we're going to add some food coloring as well. Today, our colors are a little different than normal. Today, I'm rocking out the rose pink and the sunset orange. Now, I'm going to reverse what I did on Instagram, okay? On Instagram, I did my 1X in orange, okay? And I did my 10X in pink. So we're going to go the other way around, all right? Once again, Ms. Steph here. Welcome to Science with Ms. Steph. This is episode 68, everybody, and we are having a great time learning about how multiplying times 10 can bring a whole nother level of a reaction, can completely change your results. I'm so excited to be sharing this with you today, and I'm glad that you're having fun with me. Okay? Yeah, let's kind of shift the lighting a little bit. I'm going to tilt you down so that you can see me set up our flasks, right? So we have this is going to be our 10X flask. And of course, we've got our 1X flask. Okay? As I stated before, we're adding soap. I have water in this container. And I have my Alka-Seltzer tablets already opened up and out of the little envelopes. All right? First thing I want to add is the water. I'm going to use my 250 milliliter graduated cylinder for today. The lowest that this cylinder measures is 25 milliliters and the highest is 250. So I'm actually going to be on the 2 ends of the spectrum when it comes to using this particular apparatus. Our lighting is shifted because of the weather, I think. Turn on some lights. Okay. There we go. Hopefully you all are able to see what's going on. So my 25 milliliters, once again, is going to go into my 1X container. Miss Steph here, folks. Thank you so much for joining me for another Saturday Science with Miss Steph. We rock out every Saturday at 2:30 Eastern Standard or Eastern Daylight, depending on what time of the year it is. And we do some science fun. Now, I want to be very clear. We are going to change up our format a bit come May 29th because we are going to be outside at an event. Yes, yes, friends. We are resuming. Okay, not going back. Remember I told you I'm not going to say that. We are resuming in-person instruction. All right, 1, 2, 3, 4, 5. Entirely non-scientific, but measuring soap, because it's so viscous, it's hard to do it. In a measurement device. All right, so now hopefully you can see my pink, right? And I'm going to do 1 drop of the pink. And my orange, I'm going to do 3 drops of the orange. This is one of the things we're not multiplying times 10. 2, 3. Okay? Folks, the next step is coming up. The next part, the big part, the whoa, let's find out what happens part. The excitement, okay, is building. All right? I'm so glad that you're here with me to experience this. Let's do a quick reminder of how Alka-Seltzer works. It's in tablet form, and the tablet contains 3 active ingredients. There's only 2 of those ingredients that we really care about when we're doing this kind of science investigation, when we're exploring how much gas is produced. We're looking at the carbonate, the sodium carbonate, and the citric acid. Those things combine together, okay? Those things are in the tablet. And then when you put the tablet inside of water, those things now can react with each other because they're in water. They've dissolved inside of the water. They don't react with each other until they hit water. So these tablets are hanging out. They're in the store just hanging out. And there are things that are inside that can react to each other, but only when we add water. Come on, y'all. You know that's cool. That's amazing. Okay? Now, I am going to do this particular one, our 1X reaction. That's our pink reaction. Okay? While I'm holding it up. And then I'll put the orange reaction in the sink. You know, when something goes in the sink, that means that it might just get a little crazy. All right? Are you ready? Okay, are you ready? I'm going to break this a bit because, as you can see, the tablet does not fit in there like that. Okay? Be very careful when you're doing this activity. This activity is safe to do at home, but you really just want to be aware. And just like last week, make your safe choices. We're not going to put anything in our mouths. You notice even though I'm holding this up close to my face, I'm not like splashing it or swirling it. I am going to swirl it momentarily, but you'll notice me back up when I do that. See? So we have this nice foam action. Just a little bit of soap, one measly drop of food coloring, of my pink food coloring, one tablet, and 25 milliliters of water. Now, similar to last week's reaction, even though it's not bubbling up and doing what last week did, it's still a pretty fruitful reaction, right? You see, you're getting a lot of product being my gas. My foam is my indicator that the gas was produced, okay? Was produced. Swirl, swirl, swirl. I'm swirling to make sure that the tablets are dissolving because I can see that not all of them are dissolved. They're still down there in the bottom, still dissolving. All right? Absolutely amazing. Absolutely amazing. Yes, yes. Let's do one more sound check. Can you hear me? All right, we're now going to hop right into the next observation. Remember, we're actually doing 3 observations today. We're doing our 1x and our 10x reaction, of course, just like we've been doing all of May. But then I'm also going to do a little something for you with a balloon and a Alka-Seltzer tablet and a soda bottle. A great and fun way to reuse your soda bottle and your water bottle, right? And that I'm going to show you. Look, see how this is going? So I'm going to put this over here where you're able to see it whilst I add. La, da, 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 da. There we go. You're turning with me. Thank you so much for your patience. All right. And tilt. Turn and tilt. Turn and tilt. Turn and tilt. Turn and tilt. There we go. Remember, this was our 1x. So this reaction, as it's still going, and it's actually trying to make its way out of the container. It's so funny. This reaction is our 1x. I'll remind you one more time what is contained inside of here. 25 milliliters of regular water, a squeeze of soap, 1 drop of food coloring, and 1 Alka-Seltzer tablet. Inside of here, I'm going to do 10 Alka-Seltzer tablets. Let's count them out together. Whoa, look. I'm going to put this over here. I have a foil pan over there to catch what's going on. 1, 2, 3, 4, 5. Count with me. 6. Make sure I don't miscount people. 7, 8, 9, and 10. Yep. 10 Alka-Seltzer tablets. I am going to actually add them all together. Right together. I'm going to take this. Okay. You ready? I'm going to just throw this in together. Boom. And we see our reaction has already started. Let's bring you down so that you can see what's happening. Let me make sure that you are able to really see it. Not only that, I can see here that there's a tablet that's not dissolved yet. thinks this looks similar to the elephant toothpaste reaction? What do you think? I think it's very amazing. Look, it's still hard. So as you can see, there are similarities to the elephant toothpaste reaction. The fact that we get that foam that comes up and over, our flask. However, some of what's going on here seems to be kind of a different pace, right? Doesn't it seem like this is taking longer to produce all of that stuff? Also, the foam is not quite as fluffy as what we produced with the elephant toothpaste. Because this particular gas, the elephant toothpaste reaction produces O2 gas, right? Remember, we're taking the oxygen off of the hydrogen peroxide. Okay, we're taking an oxygen off of that, okay, and capturing it inside of the soap. But this gas is actually CO2 gas, okay? So there's a different kind of gas that is happening here, okay? And apparently, it comes off differently. I find that very interesting. Very interesting, folks. I find it interesting, right? So I'm putting down in the chat, does it look like elephant toothpaste to you? Let me know. What do you think? And that question can be answered now while we're on live, or later when you watch this later. I want you to think through that, right? This is a learning experience for both of us. What did you learn today? What did it look like? Does that look like the elephant toothpaste? And does it look exactly like it? I would venture to say it does not look exactly like it, but there are some similarities. I mean, it's still going. Let me hold it up for you. It's still going. If you were to see, it's like, uh-oh. Still going. Okay, not sure what's going on there. Okay. Still going, still happening. The reaction is still happening, which makes sense. I mean, I was kind of silly, and I did add 10 Alka-Seltzer tablets to it. Okay, that was very fun for me. So you can try this at home. Now, some of you may be wondering, but Ms. Steph, what if I don't have Alka-Seltzer? Okay, if you don't have Alka-Seltzer, that's perfectly fine. There are store brands, okay? CVS and Rite Aid both sell something that is very similar, okay? And they come in like a blue container, and you can use them to do pretty much the same thing, all right? Now, seems like we're having a little bit of a situation over on Facebook. I'm not sure what's going on, but I'm going to keep going, going to keep going. And we are finishing up for today. I promised you that I would do one more thing. Okay? One more reaction. And that last reaction before we log out is going to be to add some Alka-Seltzer tablets. I'm actually going to do 3. I only did 1 over on Instagram. So I think it would be fun to do 3 over here, right? So I'm going to do 3 Alka-Seltzer tablets inside of a balloon. All right. And I'm going to use an old soda bottle. Yes, you'll notice it's my Fanta from the soda activity that I did earlier this month. All right. And yes, 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 I do want you to be thinking about your power of 10. I do want you to be getting yourselves prepared to look out for this week's feature family. And this week's feature family is actually going to be the Jones family. I'm so excited to introduce them to you so that you can see them and find out how Miss Steph Science Club has impacted them. What's their science club story? And for those of you who would like to share your science club story with us, please, you can send me an email or a DM or something. But we're excited to hear how Science Club has impacted your life, or lives rather, right? So we've got three tablets inside of this balloon, all right? And I'm going to add, let me tilt you down. Okay, 3 tablets inside of the balloon. Yes, like I said, it literally still has the Fanta label on it. All right. I'm adding really approximately 100 milliliters of water because we want to have enough water for it to react. Okay, to the bottle. And let's see if we can use our Alka-Seltzer tablet tablets, because I put in 3, to help expand this bottle chemically instead of having to blow it up with air in our lungs. Okay, let's find out what happens. Right, because we know that one Alka-Seltzer tablet produces quite a bit of gas. As you can imagine, scientists, the gas is having to fill the bottle up first and then help expand the balloon. Okay? And of course, I have to make sure that the balloon is sealed on. All right? So, yeah. Fun, fun, fun. Fun, fun, fun. We've expanded a balloon with Alka-Seltzer. Really, y'all. We had a great time learning about Alka-Seltzer times 10, right? How does that reaction change when we multiply most of the reagents times 10? Is it a bigger reaction? Oh, I think so. I think the 2 reactions were quite different from each other. Our 1x and our 10x reactions were, very different from each other. They both took a long time, though. They both made quite a bit of foam because we added soap to it. All right, well, my friends, next week we are going to do an oldie but goodie. You know it. Baking soda and vinegar. Times 10. I think this might be fun. All right. Thank you so much for watching Science with Ms. Steph. This has been Ms. Steph for episode 68 of Science with Ms. Steph, y'all. Please make sure you look at the links below and find out how you can continue to follow us, support us, and engage in the different programs that we have coming up. Once again, thank you so much for watching. And until next time.